and welcome back to the pod. Jenny here, settled in for another chat.
And Mark here. Hey, Jenny. So I was digging around this week, you know how I do, and I stumbled onto something. Pretty interesting, actually. Alibaba? They just dropped a new AI model.
Oh yeah? Alibaba stepping up again. Feels like we get news about a new massive model, like, every other Tuesday. Is this another one aiming for the biggest number crown?
Well, that's where it gets kind of curious. It's called QwQ-32B. QwQ-32B. Yeah, definitely a memorable name.
QwQ? Okay, points for distinctiveness maybe? Sounds a bit like an emoji. So, spill it. What's the story? Is it packing trillions of parameters?
See, that's the hook. It's asterisk, not times huge, relatively speaking. It's got 32 billion parameters. Now, I know, 32 times billion times still sounds like a lot.
Yeah, just a tad. My brain still struggles to visualize what a billion parameters even times looks like.
Right? But put it next to some of the other recent players. Like, remember DeepSeek-R1 model we talked about? That beast reportedly has, get this, 671 billion parameters.
Hang on, let me process that. 32 billion versus 671 billion? So, QwQ is, what, less than 5% of the size of the DeepSeek model? How does that even work? I thought the whole mantra was more parameters, more power.
That times has been the dominant idea, hasn't it? Just scale everything up, throw more data at it, make it bigger, and it'll get smarter. But Alibaba's making a bold claim here. They're saying this leaner model is performing remarkably well, especially in problem-solving tasks.
Performing well compared to
much larger models. They're putting it up against giants, including comparisons where it apparently matches or even surpasses OpenAI's own 1 mini in specific areas.
Okay, color me interested. How? What's the magic trick here? Is it trained on some super secret dataset? Or is it a different kind of training approach?
It looks like the core difference is a heavy focus on reinforcement learning, RL. We've touched on RL before, but it seems they really went all in on it for QwQ.
Right. RL. Refresh my memory. That's the trial and error learning, yeah? Like teaching a dog tricks with treats? The AI tries things, gets rewards for good outcomes?
Precisely. Instead of just showing it endless examples of text or code, you set objectives and reward it for actions that move it closer to those goals. For QwQ, they apparently used a specific two-stage RL process.
2 stages, okay. Walk me through it.
So, stage 1 was all about accuracy, pure and simple. They focused the rewards heavily on getting the correct times answers, particularly for things like math and coding problems. Just nail the solution, no matter how clunky the process.
Okay, phase 1. Be right. Got it. Makes sense to build that foundation.
Exactly. Then, stage 2 shifted the goalposts. The rewards weren't just for correctness anymore. They started rewarding the model for following instructions accurately, for being helpful in its responses, and for making the output, usable and clear for a human. Think clarity, helpfulness, and alignment asterisk on top time of accuracy.
So it's like, first, teach the math genius how to get the right answer. Then, teach them how to asterisk, explain time it clearly and not sound like a robot maybe? How to be a good tutor, not just a calculator.
That's a great analogy. Yeah. It's about shaping the behavior beyond just raw problem solving. It feels more targeted than just hoping useful behaviors emerge from a massive dataset.
It does sound smarter, more efficient maybe? Like training smarter, not just harder, by focusing the learning process.
That's the term they're using. Parameter efficiency. Getting more capability out of each parameter you have. The research paper suggests this RL scaling approach allows these smaller models to develop strong reasoning abilities without needing that colossal parameter count. It's like training a highly skilled, agile athlete versus just a giant.
Parameter efficiency. I like it. It has a nice ring to it. But okay, claims are one thing, Mark. Does the performance actually back this up? Let's see the benchmarks. Where's the proof?
All right, let's get to the numbers. On a challenging math benchmark called AIM-24, designed to test complex reasoning, QwQ-32B scored 79.5%.
79.5. Okay, how does that stack up?
Remember that huge DeepSeek-R1 model? The 671 billion parameter one? It scored 79.8% on the same test.
Wait, Seriously? 79.5% versus 79.8%? They're practically identical, despite QwQ being, like, 20 times smaller? That times noteworthy.
Neck and neck in complex math reasoning. And compared to OpenAI's O1 Mini on that AIME24 test, QwQ was substantially ahead. O1 Mini scored 63.6%. That's a gap of almost 16 percentage points.
Okay, so it seems particularly adept at mathematical reasoning. What about other typical AI strengths, like coding?
Good question. They tested it on Live CodeBench, a common coding benchmark. QwQ scored 63.4%.
And DeepSeek-R1?
DeepSeek-R1 scored 65.9%. So, the bigger model still has a slight edge in coding, yes, but QwQ is absolutely playing in the same league. Again, quite impressive for its size.
So, strong in math, very competitive in coding. Any other tricks up its sleeve?
Yeah, one other area they highlighted was performance on something called BFCL, which stands for Berkeley Function Calling Leaderboard. It tests the AI's ability to effectively use external tools or APIs. Think of it like knowing when to use a calculator or search the web to solve a problem.
Ah, function calling. That's key for making these models actually do things in the real world, right? Like booking appointments or controlling smart devices.
Exactly. QwQ scored 66% on that, which the reports described as state-of-the-art for that specific capability. This suggests it could be quite good at acting like an agent, using tools to accomplish tasks, not just generating text.
Okay, so the performance seems solid, especially considering the efficiency angle. It's not just hype. But does this mean it's flawless? Or are there trade-offs? Like, maybe it's great at math and tools, but struggles with, I don't know, writing poetry or understanding historical nuance compared to the giants?
That's a fair point, and something the research touches on. While it excels in these structured reasoning and tool use tasks, the research suggests that for tasks requiring sheer breadth of knowledge, maybe complex language translation nuances, or retrieving obscure facts, the larger models might still have an advantage, simply because they've ingested more diverse data.
So it's maybe less of an all-knowing oracle and more of a specialized problem solver?
Potentially. It's optimized for certain kinds of intelligence. Also, the heavy reliance on RL could itself be a limitation. It's brilliant for these tasks. But we don't know yet if RL scaling works equally well for all types of AI capabilities. Maybe there are diminishing returns for certain creative or knowledge-intensive domains.
Interesting. So it's not necessarily replacing the giants across the board, but offering a very compelling alternative for specific strengths. What about access? Is this another model locked away in Alibaba's cloud?
This is another really significant part of the announcement. They've open-sourced it. QwQ-32B is available under the Apache 2.0 license.
Oh, wow. Apache 2.0, that's quite permissive, right? Allows for commercial use, research.
Yep. Both commercial and research use are permitted. This is a big deal.
That definitely changes the game. I mean, running a 600 billion parameter model, that requires serious hardware, serious cache. A 32 billion parameter model, especially one optimized for efficiency, that sounds like something potentially runnable on much more accessible hardware, maybe even high-end consumer GPUs, or at least smaller servers?
That's the implication. The reports highlight significantly reduced VRAM requirements compared to the behemoths. We're probably talking needing only a fraction of the graphics memory. This could genuinely democratize access to highly capable AI. Smaller companies, university labs, even individual developers. They might actually be able to run, fine-tune, and build upon this without needing access to a national supercomputing center.
That feels like a really positive step for innovation. But, okay, here comes the but. Open source is fantastic, but it always brings up the safety conversation, doesn't it? If anyone can download and tinker with this, what about misuse? Especially with strong reasoning and tool use capabilities.
You read my mind. That's the ever-present shadow hanging over powerful, open technologies. The research acknowledges these dual-use risks. Think generating sophisticated malware, crafting targeted misinformation, bypassing safety protocols. If the built-in safeguards aren't robust enough, or if someone deliberately removes them, A capable and accessible model could be misused.
So, how do we manage that? Is it just hoping the community acts responsibly? Because, well, history suggests that's not always enough.
It's a huge challenge. Alibaba emphasizes responsible development and deployment, but ultimately, with open source, the control shifts to the users. It requires robust safety evaluations, maybe community standards, perhaps even regulatory frameworks down the line, though that's a whole other can of worms. It puts the onus on the ecosystem to develop best practices.
It's that constant tightrope walk between accelerating progress and managing the potential downsides. So, thinking bigger picture. Does this QwQ release signal a real shift? Are we maybe moving past the peak of bigger is always better towards an era of efficiency?
It certainly feels like a strong data point in that direction. Some experts quoted in the research frame this as exploring compute-efficient AGI pathways, finding ways to achieve advanced capabilities without exponentially increasing computational cost. There's also the economic angle. Training and running massive models costs a fortune in energy and hardware.
Right, the energy consumption alone is becoming a major concern.
Exactly. One analysis I saw projected significant adoption of these leaner, efficient models could potentially save billions, with a B, in global infrastructure costs over the next few years. That's a powerful incentive for businesses, beyond just the technical elegance.
So it's like the difference between needing a gas-guzzling V12 supercar for every trip versus developing a highly efficient, powerful, turbocharged four-cylinder that can do 90% of the jobs just as well, but using way less fuel?
That's a perfect analogy. And maybe you still need the supercar for the racetrack, but for the daily commute and most tasks, the efficient engine is smarter. Alibaba themselves seem to be thinking along these lines. Apparently, they're planning further work on multi-agent systems.
Multi-agent? You mean like connecting several smaller, specialized models together?
Yeah, instead of building one monolithic giant that tries to know everything, maybe the future is a team of highly skilled specialists, like QwQ, that can collaborate. One is great at math, another at coding, another at language nuance, another at using tools.
A brain trust of AIs, rather than one superbrain. That makes a lot of intuitive sense, actually. But coordinating that team must be its own challenge.
Oh, for sure. Orchestration becomes the key problem then, but it's a different kind of problem than just scaling parameters indefinitely. It feels like a potential path towards more adaptable and perhaps even more robust systems.
Okay, so let's try and wrap this up. Alibaba's QwQ-32B, a relatively compact 32 billion parameter model, uses clever, targeted reinforcement learning in two stages. First for accuracy, then for helpfulness and alignment. Punches way above its weight in benchmarks, especially math and tool use, competing with models many times its size.
Check.
And crucially, it's open source under Apache 2.0, making it accessible, which is great for innovation but raises the usual safety questions.
Check.
And this might signal a broader trend towards parameter efficiency, getting more AI smarts for less computational cost, potentially leading to specialized models working together.
That captures it nicely. It strongly suggests that brute force scaling isn't the only route forward. Smart training, smart architecture. Maybe finesse is becoming just as important as scale.
It really does make you reconsider the whole trajectory. Less about sheer size, more about clever design. It's a fascinating development, Mark. Lots to think about.
Definitely one to watch. And it makes you wonder, right? This whole efficiency versus scale thing. Boo! We'd actually love to know what you, our listeners, think. Is efficiency the future? Or will raw power always win out eventually? Let us know your thoughts on the socials.
Yeah, and what about the open sourcing of powerful models? Where do you fall on the access versus risk debate? Always keen to hear different perspectives. Okay, I think that's us for today.
All right, great chat, Jenny. Thanks everyone for tuning in.
We'll catch you on the next episode.